Assalamualaikum. My name is Muhammad Adi Nu'man bin Ahmad Fuad.
Assalamualaikum and hi. My name is Adrina Julia Nur Shahira binti Bajir Aulum.
Hey, Assalamualaikum. I'm Aisha.
We are from EE 1122B. So today, my group mates and I will present about calculus subject which is MAT 183. And in this video, we gonna talk about the subtopic of application of differentiation which is related rate. We choose a bubble in the water as the title in this type of application.
Now, I will explain to all of you about introduction. First of all, what is differentiation? Differentiation is the instantaneous rate of change of function with respect to one of its variable. You might not understand what I'm talking about, right? Okay, in simple way, you can understand that differentiation is the instantaneous rate of change of function with respect to one of its variable. Or differentiation is the process of finding the derivative or rate of change of a function. Okay, just to make all of you more clearly and understandable about differentiation means that to simply reduce a thing in its small thing, which is to make a big thing in its smallest form. That's called differentiation. Next, we go to the next slide, which is why we use differentiation. There are several reasons why we use differentiation. Okay, differentiation helps to find the instantaneous rate of change of a function with respect to an independent variable. It is also can find the velocity of a particle at a particular time by knowing the distance as a function of time, which is v equal to dx per dt.
The problem statement is, one evening, I was boiling some eggs in the pot to be served to the family for the morning meal. And I found that the appearance of air bubbles in the pot and signified that the egg was already ripe. But I wonder, why the air bubbles appears to be getting larger as it approaches the surface of the water. To prove truth of this, I have used the concept of differentiation to find the rate of increase in the water volume when the radius of the water bubble is 2 cm. We made the assumption that the radius of such water bubbles expand at the rate of 0.05 cm per second. So, after that, I'm just tell to my friend about that. So we already decide to solve the problem about volume of the bubbles in the water because the bubbles appears in the pot when the egg already ripe, and then the bubble appears started with smaller bubble, then reach the surface of water is become larger. So we need to use the formula of differentiation to find the volume of bubbles that change in certain rate. So the objective are to understand the usage of related rate formula in daily life and to know how important the usage of differentiation. When the bubble approach the surface, the size of the bubble increase.
Now, I will explain to all of you about problem solution from the previous video, which is the bubbles and the air bubbles and the eggs. We can conclude that to calculate the volume change, we need to know the spherical volume, since the air bubbles is in the spherical shape, right? Okay, I'm not good at drawing. This is spherical shape. Spherical shape. Okay, this is spherical shape. Next, the spherical volume is 4. This volume of spherical is 4/3. The volume of spherical shape is just V equal to 4/3 pi r cube. Okay, the rate of spherical volume change is represented by dV per dt and represented by dV per dr. We have dV per dt, dV per dr, and dV per dr. The rate of change of spherical, dV per dr, times, and represented by dV per dr. When it's different. So V/3 pi r squared, we can differentiate, comes dV per dr. dV per dr is equal to 4 pi r cube per I squared. dV per dr is pi r squared, 4 pi r squared. In order to obtain the rate of change in the volume of the air bubbles, the volume of the spheres that have undergone such differentiation multiplies by the rate of increase in the radius of the air bubbles. Next, so the rate of increase of the air bubbles radius is represented by 0.05. So dV per dr per dt is equal to 0.05 centimeter cube. Centimeter per second. Okay, that's dV per dr per dt. So we can conclude that dV per we can find dV per dt. This is dV per dt, dV per dr. This is 4 pi r squared. dr per dt is equal to 0.05 centimeter cube, centimeter per second. So we can find dV per dt, which is dV per dr times dr per dt. This is the change rule. So dV per dr is 4 pi r squared times dr per dt is 0.05 centimeter per second. So r is from the problem statement, r is equal to 2 centimeter. So we can change the r value, which is 4 pi times 2 squared times 0.05 cm second. Right. We can times it, we can calculate 0.05, which is 0.8 pi 0.8 pi cm cube per second. Okay, that is the last answer. So a change rule formula is a formula used to calculate the derivative of two or more functions in calculus. It is therefore known that the calculation of air bubbles volume change is 0.8 pi centimeter cube per s.
I'm going to continue with the conclusion of this work. So first of all, to summarize our work, we can conclude that differentiation is not only can be used in solving mathematical problems like in the test or examinations, but it is also can be one of the methods that we can use in our daily life. So for the example, in this type of differentiation, which is in science, it is about the air bubbles inside the water. So the problem we try to solve is why the air bubbles become bigger and bigger until it comes to the water surface. So we use the differentiation to know how and why the bubbles inside the water become larger. So this makes the objectives become more clear. One of the objectives is to understand the usage of related rate formula in daily life. So in this case, we use related rate formula to calculate and know why the air bubbles become bigger when it reaches the water surface. And the second one is to know how important the usage of differentiation. So when the bubbles approach the surface, the size of bubbles also increases. So this is the importance of differentiation in our life.